Right. So in the previous class, what we have seen, the VPN concepts, right? So what is confidentiality, integrity, and availability? When it comes to VPN, that availability was known as what? Authenticity. We were achieving availability through authenticity. When it comes to authentication, we were discussing about two types of authentication. One is source authentication. The other one was the message authentication. Now, let's try to understand this IPSec VPN tunnel establishment process. There are many types of VPNs are available. The focus is on what? IPsec. We have SSL VPN, we have MPLS VPN, we have L2 VPN, variety of VPN flavors are there. But the focus on our content is only on IPsec. IPsec is also open standard, like IP. What is the advantage of being open standard? Any new protocols can be adopted easily. Being open standard, interoperability could also be achieved. So IPsec is also open standard. IPsec stands for what? IP security. It tries to achieve all these three. What is that? Confidentiality, integrity, and authenticity. But anyway, to achieve that one, we need to take the help of some protocols. So by default, IPsec has two different protocols. What are all they? ESP and AH. ESP stands for what? Encapsulating security payload. AH stands for what? Authenticating header or authentication header. ESP stands for what? Encapsulating security payload. When it comes to AH, we call this as authenticating header. So these are all the two protocols which are available inside the IPsec stack, with which we will be able to achieve this confidentiality, integrity, and authenticity. So what all the services are being identified or offered by these two protocols? Let's say we were talking about what? Confidentiality, integrity, and authenticity. When it comes to confidentiality, integrity, authenticity, and I take the help of protocol called as ESP, all these three services are available. Means if you take the help of ESP protocol, you can achieve confidentiality, you can achieve integrity, you can also achieve authenticity. Apart from this, there is also one more service is being offered. What is it called? Anti-replay protection. What is it, anti-replay protection? So there is a possibility that the packet could be captured by a third-party attacker. What he could do, he could also replay that packet later on. So what will happen in that case, all the parameters, the confidentiality parameters, integrity parameters, and authenticity parameters will be matching on the received packet on the tunnel. So it will start processing it. If that packet could be processed by the VPN peer, and the attacker could generate more volume of the same packet, and then he will be sending that to the VPN tunnel just to consume the resources available on the VPN peer. So just to avoid that one, there is a mechanism with which the packet what we have received on the tunnel has been processed already or not could be verified. That's what we call it as what? Anti-replay protection. When you take the help of ESP, you can achieve confidentiality, you can achieve integrity, you can achieve authenticity, you could also achieve anti-replay protection. All this come by default. When it comes to what is it called? Authenticating header, yes, I can support anti-replay protection. Yes, authenticity is available. Integrity is available. Whereas confidentiality is not available in AH. If you use the protocol ESP, you have all these features. Whereas when you take the help of AH, except confidentiality, the rest of the features are available. So depending on the situation, which protocol you have to use, you can take a call. Now how this VPN establishment, how the VPN tunnel is going to be established? Let's see that one. So when it comes to VPN tunnel establishment process, there are 5 steps we used to be talking about. One is step number 1, which we call it as interesting traffic. What is that interesting traffic? Let's say, during the VPN discussion, we were talking about what? We have a general internet connection. We are going to be having what? A VPN gateway from which a tunnel is going to be established to the other side. Internally, I could have a LAN. Anything. So I have a LAN from which the traffic could be initiated. Now the point is, when the traffic is being generated from the LAN and it is hitting your firewall, now the firewall has to differentiate the received traffic, needs to be forwarded out through the tunnel, or it can be sent to the internet. Assume that this is a branch office and you are trying to access the resources available in head office and which needs to be tunneled through so that it can reach the application which is being hosted on the other side. I have a headquarters here where the application is hosted, right? So this application is going to be accessible through the tunnel from branch office. At the same time, the branch office could also access the internet parallelly. So the firewall needs to differentiate, the received traffic needs to be sent through the tunnel or sent to the internet. Right? So that's what we used to be calling it as what? Interesting traffic. Normally, most of the vendors we used to be calling it as what? Crypto ACLs. In Checkpoint, we used to call this as what? VPN domain. VPN domain is going to be identifying the traffic which needs to be tunneled. Then we have step 2. Now, see, this tunnel is going to be established over the public network, correct? Now, what all the parameters needs to be negotiated? I need to validate the source of the tunnel request. All these things needs to happen, right? So we normally call this as some sort of parameter negotiation that is being taken care by a protocol called as what? IKE. So an IKE has 2 different phases. The first phase is what we call it as an IPSec negotiation. Internet Security Association Key Management Protocol. We were talking about variety of keys. We need to know what key we need to be using, and the key is going to be symmetric or asymmetric, and what is the algorithm we will be using. Those negotiation is what is going to be happening in my phase 1. Right? So that is known as what? IPSec, Internet Security Association Key Management Protocol. And this could happen in 2 different modes. One is called as main mode, aggressive mode. This could happen in 2 different modes. One is main mode, the other one is what? Aggressive mode. So when do we go for main mode and when do we go for aggressive mode? Let's say that I have a firewall, I have another firewall over there, and I have internet connection. They are connected to this. A tunnel is being established between these 2 firewalls. So the point is, if both the parties are going to be using a static IP address on their interface where the VPN is going to be terminated. If the VPN peers are having a static IP address, we will be taking the help of main mode. In any one of the end, if I use a dynamic IP address, so you have to have at least one end with a static IP address. On the other end, if you have a dynamic IP address, then we will be taking the help of aggressive mode. If both the end we use a static IP address, then we used to be calling this as what? Main mode. If either of the end is using a dynamic IP address, then we will be using a mode called as what? Aggressive mode. So in case of a main mode, 3 pairs of packets are going to be exchanged. In case of aggressive mode, just 3 packets are going to be exchanged. Exactly. In main mode, it takes its own time for the negotiation to identify, authenticate, and negotiate the parameters. Aggressive mode, everything needs to be pushed in a packet. The initiator come up with all the possible options, what all I support. In case of a main mode, what will happen? one by one it will be exchanged. So initially it is going to be saying that this is what I would like to propose for the encryption authentication, what method we are going to be authenticating, integrity methods and all. On the other side, if he accepts, he will say yes. And then I will be initiating the DH key exchange, both the parties. Based on the DH key exchange, I will be generating a session key and which will be verified on the third packet. This couldn't be possible in your, what is it called, in aggressive mode. Aggressive mode, everything will be sent from the initiator side first. And if it is matching on the responder side, and then he will be responding back with, see, the initiator is going to be listing out a list of proposal. The responder has to choose one from the list. In case of main mode, if I have multiple proposal, one by one I will be checking it. Do you support this? Do you support this? In main mode, it will take little bit of time for this negotiation. In aggressive mode, we don't have that time. So initiator has to come up with all the list of proposal. So main mode, 3 pairs of packets. Aggressive mode, just 3 packets are going to be exchanged. So in case of exchange, if the other party is also agreeing upon on this, and they will be establishing a phase 1 tunnel. Whether it is going to be main mode used or aggressive mode used, if it is successfully negotiated, phase 1 tunnel is getting established. And what for this phase 1 tunnel is being established, that is what we are going to be discussing in step 3, which is IPSec phase 2, which we used to be calling it as what? IPSec negotiation. So in phase 1, what is that we have done? We have exchanged some information so that the channel could be secured. Inside that secure channel, the phase 2 parameters are going to be negotiated. What is that phase 2 parameter? The IPSec. Something like whether I would like to be using ESP or AH. Am I going to be using HMAC or not? Right? So the encryption, whatever we were using here, could be different here. So this, actually speaking, this negotiation is happening for securing the channel. Once the channel got secured, inside that the actual parameters are going to be negotiated for encrypting the data which will be transmitted through the tunnel. And we call this as a phase 1 tunnel, and if this negotiation successfully done, then a phase 2 tunnel will be established. Inside the phase 2 tunnel, the original data is going to be encrypted and then forwarded. And the phase 2, since the phase 2 tunnel is going to be negotiated inside the phase 1 tunnel, and we call this as a quick mode. So we are negotiating something on the phase 1 channel. What are all the things are going to be negotiated? Encryption algorithm, then integrity algorithm, authentication method, right? So that's what the first pair of packet will be exchanged. If there is a matching proposal on the other side, he will be responding back, okay, let's start using this one. And then on the second packet, what is that will be happening? A DH public key gets exchanged from A and B, between A and B, between these two firewalls, DH public key will be exchanged. Let's assume that we have A1 and A2, and this side B1 and B2. So asymmetric algorithm is what being used, and one of the keys being identified as a public key, and that key is going to be exchanged. Let's say that key number 2 is the public key. So that public key is getting exchanged between these two pairs. That is what? The second packet. A second pair of exchange in main mode. Now once the DH key has been exchanged, what they need? Okay. There was a challenge. What is that? We were using symmetric key for encryption, and as of now, for the bulk data encryption, we will be using the symmetric key. Then what would be the use of asymmetric key? Okay. Now, symmetric key cryptography is what? both the parties will be using the same key for both the functionalities. What is that? Encryption as well as for decryption. How both the parties would be knowing about the same key? Choice number one, as an administrator, you can configure that key manually on both the firewalls or both the VPN gateways. How do you do that one? Of course, since you are the administrator, you will be having the login, you will be able to log in and then you will be able to feed that key. Now, what I have is my enterprise is a huge enterprise. I have different set of administrator and this is in US and this is in India. And I have different set of administrator for US and I have different set of administrator for India. Now we would like to establish a tunnel. Now how do you enter the key on both these firewalls since the same enterprise, and do you think that we can send the key over email to the Indian administrator so that he can enter it? Then how do we know the key? How do we exchange the key? The symmetric key, which they will be using for the encryption of data. So that is where we take the help of this public key. What is that they will be doing it? So since they have exchanged the public key and they will be using the algorithm what? Diffie-Hellman algorithm. Let me say I have my public key A1, A2 and B2. I have these three keys on peer 1. On peer 2 they will be having B1, B2 and A2. These are all the keys. Peer B is having it. They will be sending let's say like that. Okay. So peer A will be sending his private key and neighbor's public key, not my public key. So peer A will be sending A's private key and B's public key into the DH process. Similarly, peer B will be sending B's private key and neighbor's public key, not B's public key. So both the parties will be sending their private key and neighbor's public key into the DH process. The output we will be getting from the DH process. Right? If you compare the output, both will be the same. That is mathematically proven, and that's the reason we are taking the help of Diffie-Hellman process. So when I send my private key and your public key, similarly you will send your private key and my public key into the DH process individually. You will be getting some output, and if we compare the output, and that output will be identical, and we call this key or this output as our session key. So, and this key, what we call it as a session key. And this session key will be identical on both the end, and that is what your third pair of exchange, what is that called? Authentication and key verification. This is what is going to be happening in third pair of exchange in main mode. Right? So there is a choice, we could use the same session key what we have generated in phase 1 or phase 2. And this is where the actual data is going to be encrypted in phase 2. But if you don't want to trust the phase 1 key, something like, because that has been negotiated over insecure channel, there was nothing on top of phase 1 channel. So the parameters whatever has been exchanged in phase 1 happened over public network. If you feel that you need more of security, another pair of DH key exchange and key generation would be possible in phase 2, and which is optional. Okay. So in phase 2, you can also exchange or generate a pair of key and then it could be exchanged, and which is optional. If I do that one, then I call it as PFS. Perfect. When it comes to configuration, it would be simple. All you have to do is check, what is it called, a checkbox. Okay. So if this successfully negotiated, we have something called as phase 2 tunnel got established. And then step 4, actually this is where the data exchange protected, encrypted, authenticated, integrity verified data exchange is going to be happening in step 4. Here there is no administrator configuration is required. If all these 3 parameters are configured correctly and they have exchanged successfully, and this will be automatic, you don't have anything to be done. Then why it has to be explained? Because I need to be talking about what? Step 5. There is something called as step 5, and which we call it as tunnel termination. Tunnel termination, not in the sense of terminating the tunnel as a whole. Now we were talking about this session key, right? We were talking about this session key, right? How long this key could be used? How long this key could be used? Something like when you have changed your Gmail password. Okay. When you have changed your corporate email password, as long as you have the same key and you are welcoming an attacker to crack the key, you are giving time for him to crack the key. So you have to you have to regenerate a new key even though the session is going to be continuous. So I'm going to be continue using the same email, but still I'm changing the password at a regular interval just to secure my email address, email access. I don't want to keep the same password for a longer while, and if I do that one, I'm going to encourage the attacker. I'm going to give more time for the attacker to crack my password. So I have to reset my password. I have to change my password at a regular interval so that I'm challenging the attacker to crack the password within that period of time. When it comes to public email, we are not enforcing it. In case of a corporate email, the company is enforcing it. Whether you like it or not, you have to change the password at a regular interval. The same thing is going to be happening on the session key as well. Session key is what we will be using for data protection. And how long I could keep that key? There is a choice of saying that one, the tunnel can be terminated or the regeneration key, regeneration. This could happen by specifying the time or load of data. When I say the time, it doesn't matter how much data you have exchanged. At that specified interval, a new key will be used. If the tunnel termination is configured based on the load, the duration doesn't matter. How much data we are exchanging, based on that a new key will be negotiated. Assume that the default is time. Every day a new key will be used. If I change it to load, that means what? If I say that 1 GB of data, if I say that for every 1 GB of data a new key needs to be used, it doesn't matter the 1 GB of data got exchanged in 1 minute or 1 hour or 1 day or 1 week or 1 month. So once that 1 GB of data has been exchanged successfully through the tunnel, a new key has to be used. That's what the point. Depending on the vendor on which you are working, you may get option to configure whether it is going to be time based or load based. The point is, if I'm going to be saying that the key negotiation is going to be happening by interval, and the configuration says that at a regular interval a key has to be negotiated, and the interval is going to be 24 hours. It is not that exactly after 24 hours a key will be negotiated, right? So it will be negotiated prior to the existing interval to be expired, and then the key is going to be kept ready, and key will be verified and then kept ready. So once the duration is over, it will start using the new key. It is not that when the duration comes, the tunnel will be terminated and the new negotiation will happen. Even before the tunnel could be terminated, the key is going to be negotiated, verified and kept ready. When time comes, the new key will be started here. We will be start using the new key. Okay? And one thing we need to be understanding, when the phase 1 got negotiated successfully, we were talking about what? A phase 1 tunnel is going to be established and it is going to be maintained in a database called as what? Phase 1 SA database. SA is nothing but a security association. And then similarly, when phase 2 parameters are negotiated and they are going to be kept in a database called as what? SA database. And this is phase 1 SA and this is phase 2 SA. Right? SA is nothing but security association. The parameters what we have negotiated and what is the key we will be using for encryption and what is the HMAC key we will be using it for message authentication, and all those things are going to be kept in a database which is known as what? Security association database, and they are going to be identified by something called as what? Security parameter index, which will be part of your ESP or authenticating header. Why is that so? When you have multiple tunnels with multiple peers, let's say that you have tunnel for branch office 1 and you have another tunnel for branch office 2 and another tunnel for partner site 1, and like that multiple tunnels could be possible. Assume that I'll be using a different set of parameters, like here let me use triple des and SHA-1 and HMAC, all these things are being used, right? Whereas, do I have any condition that always I have to use the same parameters for all the tunnels? Could be different. AES 256, SHA-1, then HMAC, could be anything. Even though I use the same parameter on multiple tunnel, I told you that in what way they differ, their key is going to be unique. Right? So AES and AES, even though I'm using the same parameters for two tunnels, they will be using a different key for encrypting the data. How do I know what parameter I have to use and what key I have to be using it? So these negotiated parameters are going to be stored in what? A database, I told you, right? SAD, Security Association Database. Like I have multiple tunnels with multiple sides, and every tunnel is going to be identified by their source and destination IP addresses. So 1.1.1.1 and 1.1.1.2, it could be anything, .3, .4. As long as the public IP address is reachable for me, I could form the tunnel. The point is, inside the Security Association database, and everyone will be maintaining the Security Association database, and they will be keeping this list in order, right? And this, for every tunnel, they will be maintaining one row. This is my row. Like three tunnels, three rows are being maintained, and these SAs are going to be identified by a number. We call it as what? SPI. And this SPI will be, my local SPI will be there, remote SPI will also be there, they will be negotiated. So I know that what is the SPI of my remote peer, and my remote peer will be knowing about my local SPI. So what for it is being used, whenever the data is being sent over internet or sent through the tunnel which is going to be encrypted, I will also be adding the remote peer's SPI number as part of this encapsulation will be forwarded to the remote peer. By seeing this SPI number, the remote peer could understand what algorithm and what key needs to be used, because that is being stored in a row, and that row is being identified by a number, what we call it as SPI. So whenever a packet is being forwarded through the tunnel, I'm saying that you have to check your internal Security Association database for this particular index number. That index number will be giving you the details of how this data could be decrypted, what algorithm you have to use and what key you have to use. Right? So those are all going to be identified by what? Security parameter index. For every association, for every communication, local SPI and remote SPI, both will be mentioned as part of your encapsulation. So this is what your typical explanation for IPSec VPN tunnel establishment process. Let's see how this could be configured